So, in the last class we went through the basics of electric circuits, DC circuits. I will just brief as to what I did in the last class. Ohm's law, V is equal to IR, and energy is nothing but equal to, generally represented by W. This can be taken as VIT, or it can be taken as I square RT, or it can be taken as V square by R into T. The unit being the joules or the watt second, and power is nothing but equal to VI, or it may be I square R, or it may be V square by R. The unit is nothing but the watt denoted by capital letter. While here the energy, while here it is the watt. So, depending upon the constant, W must be read as per the need. Then we also discussed, according to the Kirchhoff's current law, the sum of the currents at a node is 0. It is nothing but sigma IN is equal to 0, and according to Kirchhoff's voltage law, sum of the voltage equal to 0 in a closed loop. With these things in mind, we will work out few problems in that respect. A potential difference of 100 volts is applied across a 25 ohm resistor. Calculate the current, the power dissipated, and the energy transformed into heat in 10 minutes. So, as such, whenever the problem is given, it is always preferable to convert the sentences into a circuit or a sketch. It gives a much better idea. In that respect, you can see here a potential difference of 100 volts is applied to a 25 ohm resistor, means this being the resistor, voltage applied is nothing but 100. This is 100. This is 25 ohm, and this will be the current. Obviously, the current is nothing but V by R. This will be equal to 100 divided by 25 gives 4 amperes. When it comes to power dissipated, P is equal to, it can be taken as VI, or it can be I square R, or it can be V square by R. Here this will be 100 into 25, the 4, or it will be 4 square into 25, or it is 100 square by 25, gives 400 watt. Work out in any way, you should give the same result. When it comes to power, energy transformed into heat in 10 minutes, what will be that? Energy is nothing but the power into time. When it comes to time, generally it is expressed in seconds when the energy involved is less. However, when the energy involved is large, it is generally expressed in hours. Here it is 10 minutes, P being 400 into time being 10 minutes, convert into the seconds, that means 60, will give you 24,000 or 2,40,000 joules. So, that is the answer. Though this is a simple problem, it gives an idea as to how to go about further. Consider another example. What is the maximum current that can flow through a 1/8 watt 6.8 kilo ohm resistor? What is the maximum voltage that can be applied across? In that respect, every resistor will have been designed for a particular value of power, and generally it is voltage. Once the voltage and power is known, the current is also known. In that respect, P being equal to I square R, or it can be V square by R. So, in this particular problem, I know the power, this is nothing but 1/8 watt and 6.8 kilo ohm resistor. So, R is given also, this is nothing but 6.8 kilo. Therefore, I will be equal to, this is P by R square root will give that value. So, that comes to 4.287 milliamps when P is taken as 1/8 and this is 6.8 into 10 to the power of minus 3. The current should not exceed 4.28 milliamps for long time. If it exceeds for long time, obviously the resistor will get damaged. And what is the voltage that it can be applied? It can be calculated from this expression, where V will be equal to P into R under root, this being 1/8 and this is 6.8 into 10 to the power of minus 3 under root will give the value of V. So, with that in mind, that will be 29 point, this is 10 to the power of 3, this comes to 29.15 volt. The voltage should not exceed say around 30 volts. If the voltage increases, obviously current increases, heat produced also increases, therefore the resistor is getting damaged permanently. Though these are simple problems, it gives an idea how the resistors are rated in different ways. Consider the third problem. 3 6-volt 3-watt lamps in series with a 64 ohm 40-watt resistor are connected across a 50-volt supply. If the filament of the two lamps simultaneously fuses to provide a path of continuity, what will be the current in the circuit and the status of the leftover lamp and the resistor? Convert the sentences into a sketch in that respect. 3 66 volts 3-watt lamps in series with 64 ohm, this is 64 ohm and the voltage applied is 50 volts. As such, the 3 lamps have been connected. I will write this as the lamp. Out of the 3 lamps, 2 lamps have gone fused. In that respect, you will also observe if the filament of 2 lamps simultaneously fuses to provide a path of continuity. That means there is a continuity, so this is one lamp and this is the other lamp. If that is the case, if these 2 lamps gets fused out, what will happen? To understand that, find out what is the value of resistance here now. Say we know the resistance is nothing but power is equal to I square R, or it may be V square by R. In this particular problem, we know the power is nothing but 3 watt and the voltage that is nothing but 6 volts. So, with that, what will be R? R comes to, it will be 12 ohm. So, when these two gets fused out, the leftover are the resistance and the lamp of 12 ohm. With that, what will happen? To understand that, find out what is the current here now. I is obviously equal to, this is 50 divided by 64 plus 12 comes to 0.659 amperes. This will be the current. With that, what will be the consequence? To understand that, find out what will be the power loss in this 64 watt, 64 ohm resistor and this 12 ohm lamp. When it comes to 12 ohm lamp, it is nothing but power in the lamp will be equal to 0.659 square into 12 comes to, you can see here now, this is this will be 0.659. So, with that the PL lamp will be rated for this, the maximum current that the lamp can carry is, this is 659. So, with that the power in the lamp will be equal to 0.65 square into 12, that gives you around more than 3 watts. This will be greater than 3 watts. With that, this will also fuse out. When this fuses out, what will happen? Now, this will only be left out. I will repeat, when the current is more, when the current is something like 0.659 with this lamp, the heat developed will be more than 3 watts, therefore, this gets fused out. With that, this will only be left in the circuit. When that is left here, this will be this is 50 and this is nothing but 64. Then what will be the current? The current will be equal to, I will be equal to 50 divided by 64, that comes to 0.781 and the power will be equal to 0.781 into 64. That will be approximately 39 watts. Since the lamp is rated for, as you can see in the problem it has been given, lamp is rated for 40 watts, sorry, the resistor is rated for 40 watts. Since this is only 39 watts, the resistor will not get damaged even when the three lamps fuses out. So that will be the consequence. So when these two are fuses out, this will also go fused out, but the circuit continues to, or the resistor will not get fused out or will not get destroyed. So that is the consequence. Then consider an example where the resistor is used as a series circuit is used as a current limiting circuit. In that respect, a certain electronic device is rated for 20 milliamps and 6 volt. If it is to be energized from 24 volt, determine the value of resistance to be connected in series with the device and its power rating so that the device suffers no damage. Here there is an electronic circuit. This is the electronic device. It is rated for, electronic device is rated for 6 volts 24 milliamps, and it is to be energized from 24 volts. We have a voltage of 24 volts. What resistance must be connected in series with the device so that this is not getting damaged? So consider the R here now. This will be the circuit, and the current, the maximum current that can flow will be this. This being 6 volts, and this must be, according to Kirchhoff voltage law, the sum of this voltage and this voltage must be equal to this. In that respect, the voltage across the resistor can be taken as equal to, this is 24 minus 6 comes to 18 volt. If that is the case, what will be the value of this R? This will be equal to 18 divided by 24 into 10 to the power of minus 3. That gives you a value of 0.9 it is 20 milliamps, not 24. This is 20 milliamps. So this will be 0.9 kilo ohm. Once we get this, we can find out the power rating. The power rating will be equal to I square R, that will be equal to 20 into 10 to the power of minus 3 square into 0.9 into 10 to the power of 3 will give you the power rating of the resistor. That will be 0.36 watt. If the resistor is to be rated for a voltage of 18 volts or little more, and it should be rated for about 0.36 watts, so that this electronic device doesn't get damaged. Consider another example. A variable resistor R in series with a fixed resistor 22 ohm is connected across 110 volt supply. Determine resistance to which the resistor should be adjusted in order that its power may be maximum. B, current. C, the value of Rx, which will make power in it twice that in 22 ohm resistor, and the value of current. Here a variable resistor R with a fixed resistor of 22 ohm, this is 22 ohm, and this is the variable resistor R, is connected across 110 volt supply. This is nothing but 110 volt supply. Determine the resistance to which R must be adjusted so that the power in that is maximum. In that respect, what is power in this PR? Rp will be equal to, this is I square into R. What is I as such these two are in series, therefore the current will be equal to 110 divided by this is 22 plus R square into R. In order that the power to be maximum in R, dP by dR must be equal to 0. When this expression is differentiated, obviously you will get, you can see here, for this after differentiation and equating it to 0, you will get R is equal to 22 ohm. So, the power will be maximum when the external resistance connected to the source is equal to 22 ohm resistance here, or generally the internal resistance of the battery. So, that is the first one. Then resistance to which R should be adjusted in order that its power may be maximum. B, the current. I is obviously equal to V by this is 22 plus 22, or that will be 110, it will be this much. The current is, it comes to 2.5 amperes, that is the current. The next one is value of Rx, which will make power in it twice that in the 22 ohm resistor. If I call this one as say Rx, the power consumed must be here, must be twice that of this one. So, with that in mind, what is the total power? The total power will be equal to I square into 22 into the power in this one, that is nothing but I plus I square into this must be twice of this one, means you can write this one as 2 into 22. So, this will be equal to, it can be written as equal to, say this is, if I write it as Ix for the x here, so this will be Ix. So, this can be taken as, this is 1 and this is 2, that comes to 3 into 22 into Ix square, or you can write this one as 66 Ix square. This will also be equal to, you can equate it to the total power. The total power is nothing but equal to, this is I square, that is 110 divided by into the value of this one Rx. That is one way it can be done. So, these two must be equal. It must give you the power in this will be the 2 times the power in this. So, in that respect, we can see here, it can also be taken as equal to Ix square into this is 22 plus the other value is nothing but Rx, that is nothing but this. When you equate these two, you will observe this gets cancelled, and if you find it Rx, that will come to 44 ohm. So, when Rx is 44 ohm, obviously the value of the power consumed by this one will be twice that of this. The current is obviously equal to, this is 110 divided by 22 plus 44 will give the value of current. That will come to 1.67 amperes. The next problem, when 10 ohm is applied to an unknown voltage source, a current of 2.5 ampere flows, and when the load resistance is increased to 20 ohm, the current drops to 2 amperes. If a load of 15 ohm is connected across the source, what is the voltage across it? Also calculate the power dissipated in the circuit. It is a problem. Look, consider this, when a 10 ohm load is applied to an unknown voltage source. Unknown voltage source means it can be an ideal voltage source or it can be a practical voltage source. If it is an ideal voltage source, what happens? If this is V, the first case 10 ohm is connected and the current is 2.5 amperes. So, obviously, the voltage measurable across this will be equal to 10 into 2.5, that is 25 volts. In the second case, the load resistance, when the load resistance is increased to 20 ohm, the current drops to 2 amperes. In the second case, this is 20 ohm, this is 2 ampere, this is same V. Now, you will observe the voltage is 40 volts, which cannot be possible. In an ideal source, this voltage, if this is taken as the correct one, this should have also been 25 volt. Because these two are not same, it indicates that the voltage source is not an ideal one, but it is a practical one. In that respect, a practical source can be assumed to have a series resistance, this one and this one. This is V. Now, this is R. This is the first resistance is nothing but 10 ohm and this is nothing but 2.5 amperes. The second case, the same R, same V. Now, this is 20 ohm, this is 2 amperes. With that, V is equal to, this is 2.5 R plus 2.5 into 10 must be equal to, in both the cases V must be the same. In that respect, you can write this one as 2 into R plus 2 into 20. With that, if you simplify this, R works out to be 30 ohm. So, once we know this one, we can find out what's the next one is, if a load of 15 ohm is connected across the source, what's the voltage across it, and also calculate the power dissipated in the circuit. In that respect, so this is nothing but, the third case is, this is 30 ohm, this is V and the resistance is 15 ohm. To find out the current, V is equal to, if a load of 15 ohm is connected across it, what is the voltage across it? To find out the voltage across this, we must find out what is the current here now. To find out the current, I must know what is this voltage. In that respect, substitute this value of R in this equation, we will get the value of the voltage. In that respect, V is equal to 2.5 into 30 plus this one 10 into 2.5 comes to 25, or it can be connected, substituted into this also, 2 into 30, that comes to 60 plus that will be 40. So, this will be 100 volts. Whether you go for this or this, the voltage will be the same. Once you get this one, I will obviously be equal to, this is 100 divided by 30 plus 15 will give the value, and that will be this will be the current, and of course, this is with that. What will be the voltage across this? I have not found out what is the value of this, but you can directly find out this one. Voltage across 15 ohm will be equal to the current into this resistance. Current is nothing but 100 divided by 45 into 15 will give you the voltage across that. That comes to 33.33 volts. That. Once I know what is the voltage across this, we can find out what is the power. I know even current also, the power can be calculated. The power will obviously be equal to the voltage V square, V15 square by R15, that is nothing but 15, that comes to 33.33 divided by 15, this will be square, equal to, comes to 222.2 watts. Though the problem does not say whether the source is ideal or the real, the data given will give an idea as to what it must be. Think of another example. For the circuit shown in the figure, calculate the value of the current in either branch and the value of unknown resistance capital R when the total current taken by the network is 2.25 amperes. The circuit given is this. This is 10 volts. This is 2 ohm, 8 ohm, then 5 ohm. This is R. This can be taken as I1 and this is given as I2. The total current has been given as, this is given as 2.25 amperes. For the circuit shown in the figure, calculate the value of the current in either branch. In that respect, I have to calculate what is I1 and I2. So, it is always preferable to start with the value that is required to be determined. The value that is required to be determined is nothing but I1. I1 can be taken as equal to, this will be equal to, as you can observe, since these two are, since the current flowing through 2 ohm is also flowing through 8 ohm, these two are said to be in they are in series. Similarly, 5 ohm is in series with R. In that respect, the circuit can also be written as, can be simplified like this. This is nothing but 2 plus 8 is nothing but 10 ohm. This is nothing but current I1, this is current I2. I will call this one as say R1 and I will call this one as R2. This is 5 plus R. And this is the voltage 10 volts and this is nothing but 2.25 amperes. So, the value of I1 can be equal to, this is 10 divided by 10, that comes to 1 ampere. Then what will be the value of I2? I2 will be equal to, so at this point, instead of I2, we will just calculate why should we go for I2. Next, we have to find out what is the value of R. To find out value of R, I do not know what is the voltage across that. Knowing when V is equal to IR, knowing any two quantities, we can find out the third quantity. In that respect, R is not, voltage across this is not known and also the current is not also known. However, now looking into this, we know total current, we know what is the current flowing through this one I1. So, with that I know what is the current flowing through this. Voltage across these two must be 10 volts. So, in that case I can find out R2, from which you can find out R. So, in that respect R2 can be taken as equal to V by I2, where I2 is nothing but equal to I minus I1. So, this is nothing but 2.25 minus 1 comes to 1.25 amperes. Obviously, R2 will be equal to, this is 10 divided by 1.25 comes to 8 ohm. As R2 is equal to 5 plus R, R will be equal to 8 minus 5 comes to 3 ohm. It is quite a simple problem. Now, consider another problem. Two resistors are connected in parallel and a voltage of 200 volt is applied to the terminals. The total current taken is 25 amperes and the power dissipated in one of the resistors is 1500 watts. What is the resistance of each element? Two resistors are connected in parallel. This is one resistor, this is the other resistor connected in parallel across a 200 volt supply. This is R1, say this is R2. The total current taken is 25 amperes. This is 25 amperes. The power dissipated in one of the resistor is 1500 watts. In that case, you can assume it to be either the power consumed by R1 or R2. If I take it as say R1, then P1 it can be taken as equal to 1500 watts. So with that I have to find out what is the R1 and R2. As such, P is equal to V square by R. R it can be VI, R it can be I square R. In that respect, I know what's the power here. You will also observe this 200 volt is across this R1 only. In that we know V, we know P, we know V, we can find out what is R. In that respect, R will be equal to, this is V square, 200 square divided by 1500 will give you the value. This comes to 26.27 ohm. Once I get this R1, how to find out R2? In that respect, R2 is nothing but equal to V over I2. I know this 25 amperes, but I do not know what is I1 and I2. In that respect, if I take this one as I1 and this is I2, I2 can be taken as equal to I minus I1. Is it possible to find out I1? Yes. We know what's the voltage across this R1, we know what's the resistance. So in that case, I1 is known. I1 will be equal to, this is V by R1, this comes to 200 divided by 26.27 comes to 7.5 amperes. Once I get this, I2 is obviously equal to 25 minus 7.5 comes to 17.5 amperes. With that, the value of R2 will be equal to, this will be 200 divided by 17.5 will give you 11.43 ohm. That one. So this is how it can be done in one of the possible method. What could be the other method also? Can it be done in any other way? R1 is equal to, this is V square by, R1 is equal to V square by P1, that's nothing but 200 square divided by 1500 comes to 26.27 ohm. If you want to find out in the same way, we know total voltage, or we know the voltage applied to the circuit, we know total current. So in that respect, the power is nothing but equal to P1 plus P2. P1 is nothing but VI1 plus VI2 is equal to, this is V into I1 plus I2 is nothing but I, that comes to 200 into 25 comes to 5000 watts. Once I get this, P2 will be equal to, R2 can be calculated by the similar expression, R2 will be equal to V square over P2, therefore P2 is equal to, this is P minus P1, that is 5000 minus 1500 comes to 3500 watts. Therefore, R2 will be equal to 200 square divided by 3500 gives 11.34 ohm. It can be worked out in different possible ways. Every mind will think in the different possible ways and tries to work out in their own way. All of them may be different, but our answers will be the same. A large quantity of 12 volt battery, each rated at 5 ampere, are available. Design an emergency lighting system capable of providing a power of 2400 watts at 120 volt. If the cost of each battery is X, what is the total cost of the batteries? Show the arrangement of the batteries. Number of batteries are available, 12 volt battery. It is required to satisfy a load of 2000 watts at 120 volt. In that respect, since the voltage of each battery is 12 volt, to get an voltage of 120 volt, we have to connect 10 batteries in series. So that will be this. This is 1, this will be, this is 1, this is 10. The voltage available is obviously this is 120. Each battery being rated for about 5 amperes, the maximum current this can be loaded is 5. As such, to get more voltage will be the voltage sources or the batteries will be connected in series. To get more and more load or more and more current, the batteries must be connected in parallel. In that case, what should be, how many parallel circuits must be there? So we know the total power to be supplied is 2400 and it is nothing but equal to Vi. Therefore, I is equal to 2400 at 120 volts means it should be 20 amperes. Totally at the output we have to have 20 amperes. Each being of 5 ampere, how many batteries have to be, how many such parallel paths to be provided or parallel circuits to be provided? This will be equal to 4 has to be provided because 20 by 5 is nothing but 4. With that now it will be this way. Here the current coming is 5 ampere. This current gets added up to 10 amperes here. Again 5 ampere comes here, that goes to 15 amperes. And then finally the last one is this one, and here also 5 amperes, and the current that's available is 20 amperes. This is nothing, from here to here is nothing but 120 volts. 120 into 20 will give a power of 2400 watts. Therefore, the number of batteries required obviously 10 into 4, 40. The cost, total cost is obviously equal to 40x. So that is how the circuits will be, or the batteries will be connected to get the required voltage as well as the required output also. In another problem, calculate the power delivered to 16 ohm resistor in the circuit shown. The circuit is this. So this is the circuit that has been given. It is required to find out what's the power in this 16 ohm resistor. When it comes to power in 16 ohm resistor, that's nothing but P16, it can be written as, this will be equal to the current flowing through this, let us say I4. If I call this one as I4, then I4 square into 16, or it can be voltage across this 16. This 200 volts will not be available across 16 ohm. The reason is they are not in parallel, they are in series, parallel, or in that combination. So in that case it has to be taken as V16 square divided by 16, or it can be taken as V16 into the I16. The easiest way is, we can see here now, as you look at this one, if I can know what's the total current here, the current here can easily be found out by going for the network or this current divider rule, as these resistances are in series and parallel. Look at this, 16, 4 and 4, they are in series. So that comes to 24 ohm, that's in parallel with this 24, that comes to 12, that 12 will be in series with these two, that will be again 24, and that will be in parallel with 24, that comes to 12, and then it will be in series with this. Though it can be mentally say discussed, or it can be the final value can be arrived at, it has to be shown how to reduce this. In that respect, you can see here, this is 8 ohm, this is 24, this is 6 ohm, 24. We can go for one more resistor, this is nothing but 4, 16, 4, that comes to 24 ohm. Since these two are in parallel, the next circuit will be, when it comes to network reduction method, it is this. It will be this. This is 6 ohm, this will be 24 into 24 divided by 24 plus 24, that comes to 12 ohm. This is 24, this is 8, this is 200 volts. Now this 12 ohm is in series with these two 6, that works out to this is 24, this will also be 24, this is 8, this also 8. So this works out to this is 200 volts, this is 8 ohm, this is 24 again to 24 and 24 in parallel means that comes to 12. And finally, you can write this as equal to, this is 200 volts, and this will be one resistance of what value, 12, 8, that comes to 28 ohm. Once I get this value, final resistance or the equivalent resistance, the current I will be equal to, this is V by 28 or V by R equivalent, V being 200 divided by 28 comes to 7.2 amperes. So once we get this one, we can see here the current always flows from higher potential to lower potential, one thing. Current always takes the least resistance path, and at the same time the current divides equally when the resistances are in parallel of same value. With that in mind, here we have 7.2 amperes. Coming to this step, same thing, 7.2, this also 7.2. At this point the current divides. Since these two are of same value, you can say this is 3.6 amperes and this is also same 3.6 amperes. This is almost this it is same as this one, this being 7.2, this being 3.6, and this is also 3.6. Go back to the previous step, this being 7.2, here it is 3.6, this also 3.6, and here the current divides 1.8, this is also 1.8. This is same as this one. With that in mind, here you will observe this is 7.2 amperes, this is 3.6, this also 3.6, this is 1.8 amperes, this also 1.8 amperes. With that, the current flowing through the 16 ohm is 1.6 amperes. Thereby, the power is nothing but equal to 1.8 square into 16 ohm will give the power. That comes to 51.4 watts. Say mentally all this can be reduced also, and by inspection also all this can be marked. However, we can find out what's the value of current also by going for current divider, the current divider rule. Consider one more example. Find the value of R and the current flowing through it in the circuit shown when the current in the branch OA is 0. The circuit given is this. this is 10 volts, 2 ohm, this is 1 ohm, 1.5 ohm, this is 4 ohm, this is R. This is A, this is OA, it can be even interchanged also. Find the value of R, that is nothing but this one, and the current flowing through it in the circuit shown when the current in the branch OA is 0. So here there is a condition, you will also observe the resistance of this has not been given. There is no necessity also, the reason being when the current through this one is 0, it can either assume to be, in order that current to be flowing through this one is 0, the potential of this one must be same as this potential of this one. In that respect, you can either ignore it or you can consider it to be of infinite resistance. How to work out that? A little later you will understand that. Since there is no current here, these two must be at same potential with respect to some other point. What is that point? Call this one as say B and this one as C. In order that these two are to be at same potential, drop across this must be same as the drop across this. You will also observe as the current comes here, some current goes here, some current goes here now. Since there is no current flowing through this, the I1 will be flowing here. When the current is not flowing means the presence of this can be ignored also, in which case the resulting circuit will be this. This will be I2. What will be the value of R? In that respect, what is the voltage across this? Is nothing but 1 into I1 must be equal to the drop across this I2 into 4. When these two are at same potential with respect to this, these two must also be at same potential with respect to this also. In that respect, this is 1.5 into I1 must be equal to I2 into R. When these two are divided by one by the other, you will observe R will be equal to 1.5 into 4, that comes to 6 ohm. It is required to find out what is the current I2. Now, how to find out that? In that respect, since these two are in series, the resulting circuit can be written as equal to this. These two will be in parallel, that is this. This is 1 plus 1.5, that comes to 2.5. The current through this is I1 and the current through this is I2, and this is 10 volts. It is this way. This is 2 ohm. This is nothing but 4 plus 6, that comes to 10 ohm. Since these two are in parallel, it can be reduced as equal to, this is 2.5 into 10 divided by 2.5 plus 10, that comes to 2 ohm, and that will be, the next step will be this. This is I. As you can observe, these two are again in series. These two are in series. This works out to be a single resistance of what? Of value 2 plus 2, that comes to 4 ohm. This is nothing but 10. So with that, I will be equal to, this is 10 by 4 comes to 2.5 amperes. Once I know that current, this current is same as this current is same as this current. This is 2.5. When the current comes here, some current goes this way, some current goes this way. In that respect, to find out I2, which is same as the current flowing through this R ohm, we can go for current divider rule, where I2 is nothing but the total current, that is 2.5, into the resistance of the opposite branch, that is nothing but 2.5 divided by the sum of the two resistance, 2.5 plus 10 comes to 0.5 ampere. The current flowing through this is 5 ampere. The same problem can be worked out in another way. As I said, when there is no current between the two, it has been open circuited. When the voltages are same, the drop is 0, therefore it can be connected like this also. With that, what will be the resulting circuit? To understand that, we will observe these two are in parallel and these two are also in parallel. The resulting circuit will be this. This is 1 ohm, this is 4 ohm. this will be 1.5 and this is 6 ohm. This is 2, this is 10 volts. So, this can be rewritten in a slightly different way to make it more understanding. It is this way. This is 10 volts, this is 2 ohm, this being 1 ohm and this is 4 ohm, this is 1.5, this is 6. As you can observe, these two are in parallel, that is what I said here, these two, and it is in series with the parallel combination of this. So, that means this will be same as it is this. Find out the series combination, parallel combination of these two, and this being 2, the parallel combination of these two, sum of these two will work out to again 2 ohms. When you simplify this also and add up, it works out to 2, and this being 10, again the current will be 10 divided by 4 comes to 2.5 amperes. Once I get that, how to find out this current, the current flowing through this? When this current is 2.5, this current is also 2.5, and therefore, the current flowing through this 6 ohm, if I write it as I6, this will be equal to total current, that is nothing but 2.5, the resistance of the opposite branch, that is nothing but 1.5 divided by the total resistance, that is nothing but 1.5 plus 6. Again you will observe this being 7.5, 2.5 by 7.5 comes to 3, 1.5 by 3 comes to 0.5 amperes. So, the problem can be worked out in different two possible ways to get the same answer. Saka munduko. Right. We will continue with some more problems in the next class. Thank you.